All right, so you're recording now. Can people online see my screen? I think I'm sharing my screen now. Yeah. Okay. Okay. So today is our week 5 RStudio session. So we're going to learn how to use RStudio to define a function, in particular a math function, okay, and then visualize the function, so by plotting its curve. Okay. Today we talk about this using the approach that is creating a data frame first from the function, and then plot the data frame like using a line chart. Okay, that's one approach. Next week, we're going to learn how to use a thing called the step function within ggplot to plot the function curve without creating a data frame. Okay, yeah. So we probably finish within an hour, hopefully. All right, function. What is a function? You can imagine or think of function as a machine. So it must have an input and then and also an output. So you give a function something, and then the function will spit out something else. So that's called a function. It can be a mathematical function. It can be some other type of functions. Okay. Yeah. All right. So we have to know the general structure of a function in R. So we have used a lot of functions already in the first 5-6 weeks in our past workshops. Okay, we have used many functions in basic R, and also like summary is a function. Okay, it can summarize the variables in the data set. We also have functions in the specific packages. Remember, we have a tidyverse package, and it has lots of functions for us to process data, mutate, filter, select, recode. They are all functions. Okay, you give the function something to process, and then you are expecting the function to return something out of the input. Okay. But sometimes we have to define our own functions. Okay, you may have some special tasks you need to perform, so we can define our own functions. Well, remember, R is a computer programming language, so you can do whatever you like. Okay, so what is how to define a function in R? So you have to give your function a name. Okay, a name. There are some names we cannot use. They are the system names we cannot use. Okay, don't worry about that, because if you use it, you get error. Okay, but generally just name it something about your function. And then you have to tell R that the object you are going to create is a function. So assign operator the arrow pointing to your name of the function, and then you have to have a type function. Okay, and then the computer knows that, okay, the object to be created is a function, and then the arguments is the input. Okay, and then you open a pair of curly brackets after arguments, and then within the back of the pair of curly brackets, you write statements about how to process the input arguments. Okay, and what to return. Okay, every function has to return something, has to output something. Okay, remember, function is a machine. You need an input and also need an output. Okay, yeah. And of course, you can also use function within your functions. Function within functions. we will probably use it today. All right, let's do the first. Oh, just, you know, the presentation mode. So let's work on RStudio together. So I'm going to RStudio, launch my RStudio. It's too big. Too smaller. RStudio open. It's slow. All right, just this from last week. Just close them. All right, file. New file, last week. Okay, if you are working on an assignment, you'll probably have to check your working directory. Okay, choose the one that is your project folder, and then you may want to open the file. Okay. For me, I just start a new file. So let's say we're going to create a function in R, which returns two calculations. So we have a function, I call this my first func. Okay, and then that R function includes the two mathematical functions to process an input value of x, and then return two outputs value from those two mathematical functions. The first function is y equal to e to the power of minus x. The second math function is y is equal to the sine, the trigonometry sine of x squared. All right, so that's how I write. First of all, I give my function name. I just call it my first func. You can call it whatever you like. And it's a function. And then within a pair of brackets, the input argument is just x. Okay. So let me copy this one over first. Okay. So this x is just a local variable. Okay, a local object within this function. Okay. So I will use this x in my statements inside the function. Okay. So just a symbol to represent the input argument. And then within my function, I have two calculations going on. The first one is calculate the exponential of minus x. Exp represents the operator of the exponential. E to the power of something, yeah, exponential. The trigonometry thing is just sin and the x squared. Okay, all right. Okay, so these two calculations, I assign them to two objects called A and B, and then return. I'm going to return a vector. So you see, I use a C function here. C function is to create a vector of things of the same type. Okay, there are two numbers, A and B. So I'm going to combine them into a vector, and then let function to return a vector of two values, A and B. Okay, and I can name them. Calculation A comes from this value, capital A. Calculation B comes from this value B. Okay, so let me run that. So once you run this definition of this function, a function object is created. Okay, and then how to use it? Just like using any other functions in R. So just type my function name. So once it's created successfully, you will get a hint. And then what value do I want to evaluate? Maybe 2. So I want to calculate the exponential of -2 and also the sine of 2 squared, which is the sine of 4. Just run this. I get 2 values returned in my console. Okay, the calculation A is 0.135. The sine of 4 is -0.75. Okay, maybe I should name the A something more meaningful. So instead of calculation A, I probably call it exponent A equal to. So here I will probably replace exp replace calculate underscore a with exp. And then the other one I'll probably replace as a sine x squared, exp x sine x squared. Yeah. All right, so this is how to define a function. Okay. You can double check your calculation in the console. So in the console, I can write exp minus 2, enter, same value. Yeah. Any questions so far? So basically, that's how we define a function in a very simple sense, very simple case. Right. Any question from people online? Online, all right. We have 2 people online. Good. Okay, thank you. All right, next one. Okay, next one. If you want to plot a function, what should we do? Just recall what you learned in high school in year. When did we learn functions in high school? Year 10, year 9, approximately. So given a function, how can I plot the function? How can I visualize it? You need to evaluate this function at multiple points, right? So our function is a simple function. You have one input variable, which is x, okay, and one output variable, which is y. So if you visualize the function, we can draw a curve on a 2-dimensional space, okay, on a xy plane, okay. So we have to evaluate the function at multiple points. The more points you evaluate, the more precise your curve will be, all right? So how to evaluate a series of points of one function? We have to create or define a series of input values, okay? And then calculate the output value for each of the input values, okay? So I'm going to define a sequence as values as the input. So I call this one, I call the sequence of values, I call it Z, lowercase z, okay? And I'm using this seq function in R, it's the base function in R, seq, to create a sequence of numbers. We have to define starting from which value to which value, and then by means the interval, the step length, okay? So we're starting from -10 to +10 by 5. So the first value will be -10, and then +5, -5, +5, 0, +5, +5, and then +5 again, +10. So we will create 5 input values using this sequence function. And then you can use a sequence of values as the input argument for your function. Okay, let's try it. Control C. Control V. So I'm going to create a Z as a sequence of input values. It looks good, okay. And then into evaluate this sequence of inputs. Remember, R syntax is a case sensitive. If you use lowercase, make sure it's lowercase. Otherwise, if it's uppercase, make sure it's uppercase. Yeah. So if I give an input of sequence of values to my function, and then my function will calculate 2 numbers for each input value, right? So run it. There you go. A1, A2, A3, A4, A5, B1, B2, B3, B4, B5. So exponent A1, the first calculation, that is the exponent of minus 10. Minus 10, which is positive 10. And the exponent positive 5, exponent 0, exponent negative 5, exponent negative 10. And then the series of B calculations, they are the signoid of input values. Okay. So I got the 10 outputs. I have 5 input values. For each input value, I have a 2 values return. So I have a 10 output values. It doesn't look too good to me. The numbers are right. But if I want to plot those 10 points, how do we plot the 10 points? Remember, how do we do manually? You have to create a column of input values and a column output values. So we have a pairs of values of input and output, and then you can locate each point using the x and y values as coordinates on the xy plane, right? And then connect those points, you get a curve. All right. So currently, this format doesn't really make that job easy. So what I'm going to do is to change it. So I'm going to request my function to return a data frame. Okay. You can also request your function to return a list. Okay. Okay. Vector, list, data frame, they are different data structures. We will have a brief talk about them in the future workshop. When we're talking about the basics of programming R, we will briefly talk about those data structures. Yeah. So vector and list, they are slightly different. In a vector, all the elements have to be the same thing. Numbers, or character. Okay. But in a list, you can combine numbers and character into one series. Yeah, before we request our function to return a vector, C is to create a vector. Yeah. You can also request a list. Okay, and then if we request list, the return will be like this. So if I go back to modify my function, if I change this one, I replace C with a list. Okay, list, and then redefine my function. So I highlight this definition of my first function and I run again. I redefine it. This one should be a list. And then if I calculate the processed input of the series of 5 values, my output will look like this. Okay. Actually, we get two lists returned. Okay. The first list is the 5 values from the calculation using exponent function. The second list is the calculation using the signoid function within my R function, my first R function. But what I really want is to return a data frame. I just show you you can request return in different formats. What I really want is a return of data frame. That looks like something we can use to make a line chart or curve using ggplot2, right? You get a data frame of columns, and you can plot we can call them variables, and then we can plot them, right? So again, I'm going to modify my function again. So I'm not going to return a vector or list. I'm going to return a data frame. data frame, data dot frame. Data frame is also a type of structure, data structure in R. Yeah. So if you combine multiple lists, you can form a data frame. Okay. Yeah. If you combine multiple vectors, you form a matrix. Because all the elements again, I think all the elements in the matrix, they have to be the same type. You can't combine columns of numbers and the columns of characters into a matrix. That's not a matrix, that's a data frame. Okay, because one is numbers, one is letters, different types. All right, so, and then we redefine it, just rerun this definition of my function, and then recalculate this input of sequence of Z. I got a data frame now. That's what I want. Okay. Then what should I do next? Because ultimately we want to plot these two curves of these two mass functions within my first R function. So I got the two columns of Y variables, right? Y1 and Y2. I also need a column of X variable or input values. All right. So what do I do? I'm going to create a data frame object. All right. Yeah. So on this page, this part is just the function we just redefined. I'm just repeating myself a little bit, I think. Yeah. So this is my first R function. It includes two mass functions. First one exponential of minus x. Second one is a sinoid of x squared. And then I will request my R function to return a data frame. Okay. Then my input, I'm going to make my input series a bit longer, right? Before I only had 5 values from -10 to +10 by 5. We only have 5 points. Of course, the curve will not look very good. Okay, 5 points, you will not have a nice looking curve. So I'm going to make my curve more precise. Okay, so I'm going to request create this input sequence. It's from -1 to +6 by 0.1. So how many input values will I create? And you can think about it. -1, -0.9, -0.8, all the way down to 0, 0.1, 0.2, 0. Blah, 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 blah. So I think we will have a 71 input values. I think I'm right. One to 10, 1 to 10, 1 to 10. We have a 7 groups of 1 to 10, and then 0. 71 input values. All right. All right. So how to create a data frame object from your function? That's easy. Because my function will return a data frame, I'm just using my function with an input of sequence of values, and then I'm going to assign the return to a data frame object. You can name it whatever you like. I just call it func data. Okay, I just call it func data. Bit too squashy. Okay. And I also need a column of X variable. The column of X variable comes from the sequence lowercase z, right? So I'm using the mutate function in tidyverse to do the job. So mutate is very useful. It can do many things, right? You can use mutate to recall variable. Yeah, you can also use mutate to create a variable using existing variables in a data frame. And you can also, here I'm using mutate to combine a data frame, func data, with a sequence Z. Basically, I'm going to add the sequence Z into my data frame as the column called X. A bit complicated. I think next time I'm going to name them using a more meaningful example. Yeah. like a distance, time, something like time, distance, something like that. Yeah. All right, so let's do it. So my function is defined already in R previously, which is here, which is here, as you said, as you can see, return a data frame. So I'm going to redefine my Z sequence. It's from -1 to +6 by 0.1. So -1 to +6 by 0.1. You can change the settings here. You can make it, you can request a plot of a different range, or maybe a smaller step or larger step by, doesn't matter. Okay. Redefine the Z, run. And then if I run my function Z, I will get this 71 rows of output values, 71 rows, 2 columns. Okay. And I'm going to assign this output data frame to an object. I call this my func data. Once I run this row, I will have a new data frame object showing up in the global environment. There you go. My func data is a spreadsheet now, okay? 2 columns, 71 rows. Okay, now I also need the input column, the X value. Remember XY plot? To plot the curve on the XY plane, you need an X value variable and the Y variable. Okay, we have 2 Y variables now in the data frame. We need a column of X variables. You can export your data later if you like. Remember in the first week or second week, how to export a data frame to a CSV file or TXT file. If you forgot, just go back to that workshop using the table, red table function. You can export your data into a spreadsheet. Okay. All right. Next step, I need to do this one. I need to use a mutate function in tidyverse. I need to load tidyverse first. Go back to my syntax. I'm going to load my tidyverse package. It will take a few seconds to load. See the red light there? Really? That long? Oh, my version be old. It's fine. Just warning, no error. And then using the mutate function in tidyverse, I'm going to combine my existing func data with the sequence of Z to make a new data frame called func data. So I need to modify my syntax. So just copied from my PowerPoint that I named. Today I named them a little bit differently. Okay, so this func data is this one, is the existing one. And then I combine the existing one with 2 columns only with the sequence of Z that is here. And then I will form the new my func data. Okay. Put my cursor here, it can run this line. It seems okay because it says 71 observations, 3 variables now. Okay, I think we get everything ready. We get data frame ready. The input column is X. I have 2 output columns, Y1 and Y2. I should really name them differently, not calculate B or calculate A. It sounds weird. So I can plot 2 curves on 1 plot. What do we do next? How do we make a plot from data frame? ggplot2, right? ggplot2 is the thing we use a lot. So basically now we have data here. And then we just need to visualize the data using statistical graphs. Right? So ggplot2, library, ggplot2. We definitely will finish very soon today. Control Enter. Loading that quick? Oh, okay, good. All right, so that's the ggplot2. It looks big, but I think you should feel a bit more comfortable now with ggplot2 after 2 weeks of ggplotting with us. So ggplot, the data is equal to, okay, I need to name it differently because this from my slide. I think I will call them my func data, right? And then the horizontal axis comes from the variable capital X, okay? And we have 2 geometry lines, okay? We have 2 geometry lines. So the first line is for calculation A, and the second line is for calculation B. Okay, the background is a black and white. And then I just also label the horizontal as just X and the vertical X as Y. That's terrible. Okay, I colored them differently, and also I colored them. I use the function as a color label. Lydia can tell us how to make the label look more mathematical. Okay, currently it just looks a bit like how to make the square properly, like in upper right corner, something like that. Yeah, okay. All right, let's try this one. Control C, Control V, and I need to change my function data set name. It's called my fun func data. I think everything else should be right. All right. Double quotation marks looks good. All right, give it a try. Please. Fingers crossed. Run. Yay. All right. So it looks fine. X variable, Y variable. I have 2 curves that come from these 2 mathematical functions because I colored them. I used this math functions as the color labels, so they show up here. Okay, yeah. Math functions. And the red one is exponential function. Exponential minus X. So when X is small, is large. When X is large, it's small because it's a minus X. And the exponential of 0 is always 1, right? So it passed the 0, 1 point here. Yeah. And the sine function, it's not sine X, it's a sine X squared. It's kind of the period becomes smaller and smaller and smaller, right? That's kind of bouncing faster and faster and faster. you can make the range be larger. Maybe we can plot from -1 to +10. You can see is more squeezed when the x is larger. I think that's probably all for today. I mean, that's probably all for today. Even faster than I expected. And then next week we will learn how to plot the same thing, and then combine these two functions to make a new mass function. And then we're going to learn a new approach next week. We're going to use the step function in ggplot to plot functions, mass functions in one graph. So we don't have to explicitly create a data frame first. We don't have to do this like we did today. We just use a step function inside ggplot to plot whichever functions we like, mass functions we like. Okay, but there are two different approaches. Yeah, this approach you have to create the data frame yourself, and also create the input sequence there, and you have defined from where to where, and then how small or how large the step is by. Okay, using the step function next week, you still have to define from where to where, and then you don't have to worry about the input values, and you don't have to worry about creating a data frame. It's all done in the background by the algorithm automatically. Okay. Yeah. Any questions? Yeah.
Many overlay bar.
This one, yeah, here are two functions. Yeah.
Assembling a data frame, same length, 10 rows.
Yeah.
And then columns of each individual subject, and then you just add a column sequence of 1 to 10 by 1.
Yeah.
If you had 10, if the data frames you were adding together were 10 rows long, then you just, and they were all y values that you wanted, like create a line for each one.
Yeah. Yes.
Then you just add that sequence object of like the same length, like from 1 to 10 by 1. So it was the same number of rows.
Yes, that's our input. Yeah. So this x from the input z sequence. That's the two calculations. Of course, every input has an output.
Like add something specific.
Yeah.
That's
thanks.
As long as they're all the same number of rows. Like.
Yes. As long, I mean, they will be, because that's from this calculation A, calculation B. They come from the. Yeah.
Like if you have a series of data sets already, which are, for example, 10 rows long. Say you have 5 subjects, 10 observations of each subject, then, and you want to plot a line each one of those subjects, then you just add x variable. Those will be y variables that you're plotting, and you just use geom underscore line.
Yeah. Yes.
Equals subject 1, 2, 3, 4, 5.
Yeah.
And then for your x axis, you just add a sequence of 1 to however many rows.
Yes, just right. Row number or row ID, doesn't matter. Yeah. Yeah.
Like you could just
1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Which would be like the same, just a different way of doing the same thing.
Yeah.
Like making that the vector that we made, which was a sequence from -1 to 6.
Yes.
But say you make it from 1 to 10.
Yeah.
And as long as that sequence is the same number of rows as the subject, it's like the y, the y values. As long as it was the same number of, yeah, I think that answers my question.
Yes. You can give a try, see if it works. If it doesn't work, you can figure out. Yeah. Because just like once you get a data frame like this, the data set, it's just like using ggplot to visualize the data. You can plot as a line. You can plot as a bar, geometry bar, if you want. Maybe not bar.
Because then it'll be like you wouldn't be able to see.
Yeah.
But yeah, specifically for a line, you could do that.
Yeah, you can use a scatter plot. You can see the points. But again, mathematically, we have a function. We always want to plot the curve of the function, right? So we use a geom line. You can see it's the line is not 100% smooth because it looks good enough, but you can see here it's not really smooth because we evaluate 71 points for each function, for each curve, and then ggplot just connect those 71 points with very little straight lines. So it looks not too bad from here. It looks quite smooth, but it actually is not a smooth curve. We use a very short straight lines to connect the 71 points for each function. So we have 142 points here, 71 points for the red curve, 71 points for the green curve.
12 individual line graphs that you want to superimpose on each other. This is how you do it.
Yeah, you can have a multiple y's, many columns of y. You can just plot them onto one plot.
So say if I had.
All right, I'll probably just finish recording today. This one is done for today. For people online, if you can, please also fill the attendance form.
Yeah. I'll show you. So if I was planning to find.
There's the attendance form for people online. Finish the recording today.